Hello and what's up to you all awesome and beautiful, wonderful mindsetters. My name is Abram and we're in for a lovely show together. It is a lovely afternoon. I hope you enjoyed your day at school. Today we're doing physical sciences right here on your favorite learning channel. I'll be with John today. John, how are you?
I'm really well, thanks. Nice to be with you as well, grade 10s. And we're doing a continuation of work that we started last week when we introduced that amazing concept called the mole. Now, we're not talking about furry creatures, Abra, the little things that dig in the ground. No, those are another type of mole. We're talking about moles in chemistry. And I've got some interesting questions for you, and I hope you're going to follow along. Get the notes. Where can they do that?
Well, guys, you need to jump to our Facebook page because already we have the links there. Our Facebook page is facebook.com/learnextra. But always, if you missed any of our notes, whether it's last week or last year or last term, you can go to learn.mindset.co.za. Otherwise, also follow us on Twitter @learnextra. But today we've got awesome things for you guys. We've got awesome giveaways. Firstly, we've got this awesome Casio calculator giveaway. You know it by now. If you don't, all you need to do is to get the notes, and on the notes there's the test yourself questions. If you answer them correctly, you stand a chance of winning this awesome Casio calculator.
Where do they get the link to enter?
The link to enter is on Facebook.
And it goes Curio dot. Is it right? Just there's a link to Curio, hey? So you register on Curio and make sure that you fill in today's code. Get that from Facebook.
Of course, everything is on Facebook, but there's another great competition that I'll be telling you guys more when the time goes on. But all you need to do is to jump on Facebook, guys.
Okay, guys, I think we've had enough of the announcements, but there are lots of things coming up. So make sure you don't miss out. There are amazing competitions, and there are some awesome prizes to be won as well. So let's get on to the lesson, mole calculations. Now, in today's lesson, what we're going to do is we're going to work with the concept of the mole. We introduced it last week, and we're going to see how we can apply it. We're going to revise something that we did last week, Avogadro's number. We're going to revise molar mass. We're going to look today at molar volume and concentration. Those 4 factors or 5 factors all link together to round our connections off in terms of this mole concept. And you need to be able to apply them, and we're going to show you that in the summary. So we're also going to explain the difference between something called an empirical formula and a molecular formula. And then the favorite part, we're going to solve problems using the mole concept, using equations, using a whole lot of ratio calculations as well. The key word here is ratio. You need to be able to understand what a ratio is and how to use it. Very, very important. So to get with that hint, let us get started. And we're taking the theme of water. Now, in the last couple of weeks, we've been dealing with the importance of water in our environment and the importance of water to us as individuals. We've put out a challenge. It's the Water Game Challenge for 2014. The details are, as you can expect, on Facebook. Okay? And guys, you haven't got a lot of time. The entries close on the 18th of August. So you've literally got the rest of this weekend, the weekend, to play the water game. So get the link. It's on Facebook and it's in the notes. And let's talk about what water's all about. And so here's the challenge question. We've been using the challenge question to link to the water challenge. And this one says that water decomposes into hydrogen and oxygen during electrolysis. So in other words, we're using electricity to separate the compound into its elements. So the compound into its elements. It's a decomposition reaction. So those are the 2 elements. And what it says to us as follows. It says, what mass of water is required to collect 25 centimeters cubed of oxygen and 48 cubic centimeters of hydrogen gas at something called STP. So guys, there's a challenge question for you to think about. It's a really practical, interesting concept that water, the molecule water, written as H2O, can be broken apart into hydrogen and oxygen. We want to do some calculation with that. So remember, look after water, play the water game, and make sure that you learn as you're doing that. So getting back to moles, when we think about learning this topic, there are different ways of doing it. And we've given you some notes which have got all the detail in it. But another way of learning the key concepts is to create a concept map. A concept map or a mind map is, some people find a really interesting way. So I wanted to show you how we can link the concepts. And what we're going to say here is the number of moles is the key thing. So how do we link number of moles to mass? And there is a linkage between number of moles and mass, and we put a line there to indicate that. What we're first of all going to say is that there's a formula or an equation that says the number of moles is equal to the mass divided by the molar mass. And I'm just going to make a note there that the molar mass is found on the periodic table. So let's just have a look at that. Periodic table, and we add all the relative atomic masses. So if I take a periodic table, there we go. It's a little small, but you can have a look. The big number at the bottom is the relative atomic mass. When we add those together for a compound, we will get the molar mass. Now, what about the link between the number of moles and number? So the number here could be number of atoms, it could be number of molecules, it could even be electrons or protons, but not often. It could be ions. That special number of what is 1 mole is called Avogadro's number, and the equation that we use is the number of moles is equal to is equal to the number that we're given, the number in the sample, the number we need to find, divided by Avogadro's number. Remember, Avogadro's number is 6,022 times 10 to the 23. A very big number, but it's a very important number. Remember last week, we spoke about it as being the same as a dozen, or as a gross. We said 144 is a gross, 1 gross. 1 dozen, we all know, is 12. And here we've got another collective word for a big number. This is a very big number. The number is 6,022 times 10 to the 24. So 23, sorry, not 24. Very, very important. Now, not all things are easy to mass. Solids and liquids, yeah, we can find their masses. But when we come to gases, it becomes a little bit more difficult. So, especially for gases, we're going to recognize that there's another link. This is for gases. For things in the gaseous state, there's a relationship that I need you to understand. That 1 mole of any substance, of anything, will have the same volume. Same volume at at the same temperature, under the same conditions. Same conditions. Now, if you think about that, so if I have got 1 mole of hydrogen, and I have 1 mole of oxygen and 1 mole of nitrogen, they will have the same volume under the same conditions. But those volumes could be different because we could have different temperatures, we could have different pressures. So we've standardized. We need to have a standard. And so we have chosen to work with a standard just so that we can do comparisons and recognize things. We're going to say 1 molar volume is equal to 22,4 decimeters cubed at standard temperature and pressure, where standard pressure, standard temperature, first of all, is equal to 0 degrees Celsius. We use in science a different term, which is 273 Kelvin. You'll learn about that next year. And standard pressure, we're going to say the standard pressure is 101.3 kilopascals. So what's the relationship? Well, if you look back, look here, we've got a kind of a standard for 1 mole. That's for 1 mole. And these other things are for the sample. So I reckon that the number of moles is equal to the volume of a sample divided by the volume of 1 mole, which is 22,4 at STP. So there's the relationship. I hope you can see the pattern. Those 3 things link together very nicely. So we can expand and explore the relationships. There's one last thing that we want to talk about in terms of this particular summary, and that's sometimes we make solutions. Take a solid, dissolve it in a solvent to make a solution. We dealt with the aqueous solutions about 3 weeks ago. We want to know how much stuff has been dissolved. How many ions are present? Well, we call that the concentration. The number of moles of solute divided by the volume of solution. So let me write that. Concentration is the number of moles of solute, the thing that gets dissolved, divided by the volume of the final thing, the solution. So if I have 5 grams of sugar and I dump it into some water, I mix it together, make sure it's all dissolved, and I then measure the volume of the final solution. Because you see, the sugar is going to take up some extra volume adding it to the water, so I can't measure the volume of the solvent. I've got to measure it once it's dissolved. Sometimes the volume actually decreases. Sometimes because the sugar or the solute gets into the spaces between the water and it pulls the water molecules closer together. We won't get into that, but that's how we've made the definition. The units of concentration are in mole per decimeter cubed. Volume, I should have said here, the units that we're going to use are decimeters cubed. So just remember, we always try and work with decimeters cubed, like I've indicated over there. Now, there's 2 little terms that I need to add to this collection of relationships between moles, and you need to know these. And it's really straightforward, but let's get them done. So there is this word called empirical formula and molecular formula. And I've put them next to each other so we can make a comparison. I'd like to put them in a different color so that we can do some comparison here. This empirical formula is the simplest ratio, and I should really say whole numbers. So we have whole numbers of elements in a compound. So it's the simplest ratio. So like 1:2. I'll give you some examples in a minute. This one, the molecular formula tells us the actual, the number, the ratio. Sorry, let's just put this. It's also a ratio, but it's the ratio of atoms of different elements in a molecule. In the actual, it's real. It's how it exists in the molecule. So let me try and give you a couple of examples. Let's take one substance, hydrogen peroxide. Now, hydrogen peroxide has a molecular formula of H2O2. So if we had to draw the molecule, we'd find that it looks something like this. Right? Molecular formula. It has extra bonds here. We won't go into that, but recognize that there are 2 hydrogens and 2 oxygens joined together. So that is one case. But what's the simplest whole number ratio over here? So if we go back to the empirical formula, we'll see the ratio is actually 2:2 in the molecule. The empirical formula then is HO. It's a ratio of 1:1. So be very clear about the difference between these. The one is the actual number that exists in the molecules, and the other is the simplest ratio. Let me do one more just to give you a clearer insight. If we take something like ethene. Now, the molecule ethene has this formula, C2H4. That's the molecular formula. But what's the ratio? Well, the ratio is not 2:4. We can cancel it down. There's a common factor here. 2 will go into itself once, and 2 will go into itself twice over there. So this is CH2. Can this exist? Can this exist on its own? As a molecule? No way. Can this exist? The molecular formula? Yes, it can. With that, Abram,
Thank you,
over
John.
to you before I sneeze.
Thank you so much. You've already sneezed. Well, my sisters, since our challenge question is all about water, check out the game which is called the South African Water Game on www.watergame.co.za. Remember, on Facebook, hashtag SA Water Game. For more information, find them on Facebook. We'll see you after the break. Welcome back, awesome Mindsetters. If you just joined us now, you're a bit late, but you can still catch up because there's more in store for you guys. We've got this awesome competition. It is Get Connected competition with prizes proudly sponsored by Vodacom. All you need to do is to jump on our Facebook page, check out the post with all the details, the instructions that tell you that firstly, you need to go to Curio. On Curio, you register if you haven't registered, and after registering, you use your code, which is LEARN, LEARN, learn. It might be lowercase or uppercase, it's up to you, but it should be learn. That's the code on Curio. After registering, you'll see the teachers there. We've got 6 teachers that would like you to vote for them. After voting for your favorite teacher on Curio, you then go on Facebook, like their picture. We have a post which is pinned on top. You must check it out on Facebook. You like your teacher's picture, and then share the post with all other friends, and you could stand a chance of winning an awesome airtime. Yesterday, we gave away with so much airtime, so you could also get that airtime. But, Joanne, yes, the prizes. The prizes. We've got awesome prizes. We've got 4 Sony Xperia cell phones. So that's so cool, guys. And over 60-55 rand airtime vouchers from Vodacom.
Brilliant, eh? Thanks to Vodacom. Now, guys, the important thing is if you entered last week, do you have to enter again? No, for the Xperia? No, you've done it.
No,
you've done
don't.
it. All you need to do is make sure the likes for your teachers, and we've just been looking at the likes. There's some very close ones there. Some within 2 of each other. Now, remember, only 2 teachers from this round go through to the next round. So you need to make sure that your favorite teacher gets into that next round. So guys, get liking, get sharing, make sure that as many of your friends know about it, and get them to tune in and watch as well. Okay, so can we get on with the lesson now?
Please.
Right, so here we go. Question number 1. We're looking at some concepts about the mole, and in question number 1 it says the following. A helium balloon contains 2,4 grams of helium gas at STP. Now, all it's telling us is that, remember, that means we can use that the volume of 1 mole is 22,4. That's when you see STP, that's what you know that you can use. Okay, so it then says to us, how many moles of helium are there in the balloon? Well, we're going to say we've been given something about the mass. Okay? We don't know anything about the volume at this stage. So we know it's helium. So if we're given mass, we need to work with the mass equation. We're asked the number of moles. Number of moles is mass over molar mass. So where do we go? We're going to go to the periodic table, and always make sure you've got your periodic table out so you can see there the big number at the bottom is the relative atomic mass of helium, which is the molar mass of helium, because helium is a monatomic gas. It exists as molecules of a single atom. Noble gas doesn't combine with anything. So I'm going to say to you, the molar mass of helium is 4 grams per mole. So we want the number of moles. We know that the number of moles is mass divided by molar mass. And the mass that was given, here we go, we were given the mass, there it is, take it off, 2,4, divided by 4. Now, you could use a calculator, but you should really know that 4 into 24 goes, how many times? 6, yes, so that's 0,6. And what is this? 0,6 mole. Let's just check it on the calculator and make sure the calculator is working. So we're going to say, there we go. Let's just choose that one and make sure that we've got the calculator up. In fact, turn it on to select, and we're going to say 24. Clear. See, that's why I wanted to check the calculator. 24 divide, oh, so it wasn't 24, it was 2,4. 2,4 divided by 4 gives us 0,6. So my answer wasn't incorrect, it was in fact correct. Let's move on to the next part of the question. And we want to go to this one. It says, what is the volume of the balloon? Now, guys, what you need to understand is the balloon will blow up and increase or decrease in terms of its number of moles present. The temperature and pressure, we're told, was at STP. So we don't have to worry about that because it's hot day, it's going to get bigger. No, this is at STP. So we're now going to use the volume formula, and we're going to say, we know that the equation says on the data sheet, the number of moles and volume are related as follows. The number of moles is equal to volume divided by molar volume. We want to find volume. God, the important thing here, so you don't lose marks, is put down the formula as you see it on the data sheet. Don't try and change it. There's a mark for getting the correct formula. So put it down. And then the next thing we're going to do is we're going to do the substitution into the formula. We're going to say the number of moles is 0,6 is equal to the volume divided by the molar volume. The volume of 1 mole is 22,4. So what is the volume? Therefore, the volume is equal to 0,6 multiplied by 22,4. And I'm not going to chance this in my head. I'm going to use the calculator. I'm going to say 0,6, which is on the calculator, times, let's just turn the smart ink off for the moment, times 22,4, and we get an answer of 13,46. Now, if you're not sure whether you've got the right answer, let's think about it this way. 0,6 is very close to 0,5. And 0,5 is a half. So if we take half of 22,4, we know that's going to be about 11,2. Well, it is 11,2. Easy to do that. So we can expect the answer to be a little bit bigger than 11,2. And yeah, it's 13,44. It looks like it's the correct answer. So we're going to write that down, 13,44 decimeters cubed. That's quite big. Remember, 1 decimeter cubed is 1 liter. 1 decimeter cubed is equivalent to 1 liter. So we've got 13 liters. This is quite a big balloon. Okay? But notice something, that it had only a small mass, only 2,4 grams. So you can see that even though we've got a very small mass, it's very big volume. Helium itself we know is not a very dense gas. The particles move apart from each other, and that's why we use helium to lift balloons and use them in dirigibles and all that sort of thing. Okay, let's move on. We want to link now, do the third link, and it says to us how many helium molecules are present in the balloon. Now, this isn't a trick question. Remember, every molecule of helium is actually an atom of helium. So we recognize that if we can find the number of atoms of helium atoms, then we found the number of molecules. The number of atoms are related in the following way. The formula on the data sheet is the number is equal to the number in the sample, number of moles is equal to the number in the sample divided by Avogadro's number. We use that by substituting in what we know. And we know that we've got 0,6. We know that Avogadro's number is 6,022 times 10 to the 23. Let's just lift that up so that we can see a little bit easier. And we want to find n. So now that you've substituted, and you would get a mark for giving the right formula, you would get a mark for the substitution, you might even get a mark, another mark. The important point is we can therefore, the number of molecules, remember molecules and atoms for helium are the same thing, but it asked you about molecules. Molecules of helium is equal to 0,6 multiplied by 6,022 times 10 to the 23. Right. Let's do that on the calculator. Pull out the old calculator and let's clear that first of all. And we're going to say 0,6 times 6,022 exponent 23. And there we've got the power, and we get the answer of 3,6132 times 10 to the 23. Now, we only need to write to 2 decimal places, so I'm going to write 3,61 times 10 to the 23. Say 3,61 times 10 to the 23 atoms or molecules, but because the question asked me for molecules, I'm going to write down molecules of helium. I just have one thing to say to you here. Guys, remember that if they gave you a diatomic gas, so something like oxygen or helium, I'm sorry, not helium, hydrogen, or even chlorine or fluorine, or one of those, that's diatomic, then you're going to need to adjust. The number of molecules is not the same as the number of atoms, but here we know the number of helium atoms is equal to the number of helium molecules. And that's a very important thing. It is just simply H. Doesn't combine with anything. And for that purpose, we know that we're dealing with a molar mass of 4 grams per mole. If we were dealing with a diatomic gas, then the molar mass would be double what you see on the periodic table. Okay, let's move on. We're moving to question number 2. The next part of this, in this question, what we're dealing with is a concentration question. We're told that we've got 25 centimeters cubed aqueous solution of sodium chloride is made up using 4,8 grams of salt. So the first thing they say to you is, what is the concentration of the solution? Now, we need the number of moles. Concentration is moles of solute divided by volume of solution. So we've got the volume of the solution, but we haven't got the number of moles. So we're going to have to find the number of moles of sodium chloride. I like to put down what I'm doing as a subscript. So I'm going to say the number of moles. What were we told about the solute? We're told that it's salts, it's sodium chloride, and we've given a mass. The mass is equal, the number of moles is equal to mass divided by molar mass. So let's work out the molar mass of sodium chloride. Go to the periodic table and let's pick it out. So on the periodic table, we're going to say, over here, we've got sodium 23. We know the formula is NaCl, so 23 plus 35,5. We're going to add those two together to get the molar mass. So we're going to say 23 plus 35,5. And again, you can use the calculator to do this, and it always is useful to check yourself. I also like to estimate 23 plus 35,5, and you're going to see that it's about 55. And there we go, 58. That's right, because 3 plus 5 is 8, and 2 plus 3 is 5. So we get 58,5 grams per mole. So we now know the molar mass. What we've got to do is we've got to find the number of moles first of all. So let's get the number of moles. We know the mass was 5,8, and this one was 58,5. So what's the number of moles? I hope you can see that it's not going to be difficult. It's 5,8 divided by 58,5, and there it is, 0,0991. Now, remember, you've got to round off to 2 decimal places. And even at this stage, you round off to 2 decimal places. Don't use the whole thing on the calculator. So to 2 decimal places, I realize that the third place is a 9. I'm going to round that off and so say that the answer is 0,10. So let me write that in. I'm going to round that off and say this answer is 0,10 moles. I'm going to just get rid of that so I've got some more space to work with, because the next part of the calculation is the key part. The key part, we're going to say concentration is the number of moles divided by volume. The number of moles, 0,1, and the volume was given as 250. Now, do you think I can leave it as 250? No, it said centimeters cubed. What is concentration units? Mole per decimeter cubed. So I must change it. How do I convert from 250 to decimeters cubed? Well, you know that 250 milliliters is about quarter of a liter. So that was a terrible 5, 0,25 decimeters cubed divided by 1,000. So I'm going to do exactly that over here and divide by 1,000 and get my answer. So I'm going to say 0,1 divided by 0,25 equals 0,4. So 0,4 moles per decimeter cubed. That's the concentration. That's the concentration of the solution. Now says to me, notice how it leads on. How many ions of sodium are present? Well, I started with sodium chloride. Do you remember what happens when sodium chloride, salt, table salt, dissolves in water? Yes, it dissociates. We can write it as NaCl solid in an aqueous solution will go to form Na plus Aq plus Cl minus Aq. So what do you notice in this case? Remember, for every 1 mole of that, I'm going to produce 1 mole of that. So if I know that I had 0,1 moles of that, don't you think it's true that I have 0,1 moles of that, of the sodium ions? Absolutely, because the ratio is 1:1. Notice where I'm getting it from? There's the number of moles present. Always go back to number of moles. So moles, and now it says how many ions. So now I'm going to say the number I'm looking for is the number of ions. I'm going to use the formula that's got number in it. And so let's substitute into that. What do we know? we know that we can say, therefore, 0, 1 is equal to the number that we're trying to find times Avogadro's number, or divided by Avogadro's number, is 6,022 times 10 to the 23. And we can then get, therefore, n is equal to 0, 1 times 6,022 times 10 to the 23. Now, that's not too difficult to do. You can even do it in your head, because if you divide, you multiply by 0, 1, it's like dividing by 10. If you divide by 10, you're going to knock down one of those powers, and the answer, I'm just going to put the answer up here, is going to be 6,022 times 10 to the 22 ions of sodium. Okay. Now, we've run out of time for the last question, but it's a really interesting question, so we'll come back to it before we do the challenge question after the break. AB, over to you.
Thank you, John. And Mindsetters, if you have some questions, make sure that you feel free to throw them at me on facebook.com/LearnExtra. Like some other Mindsetters, such as Tabo Letlape, says his teacher already has finished the syllabus, so I'm sure that you're going to be helping other Mindsetters. He was very, very fast. Well, Mindsetters, let's help one another on the page. We'll see you after the break. Welcome back, Mindsetters. Now, the moment that we've all been waiting for since last week to announce our Casio calculator winner for Physical Sciences Grade 10. And our winner is Katlego Mudupi. Congratulations to you, Katlego Mudupi. This awesome Casio calculator is coming your way. We'll be in contact with you. So, guys, if you'd like to enter the Test Yourself question, links are on Facebook. So check them out. It'll take you straight to Curio, and there's also a code that is provided for you. So enter that code and answer those questions. Winners of this week will be announced next week.
I must say something. Congratulations to Katlego, because you know what? He was one of those learners that got 100% on the Test Yourself.
Wow.
So not many people get 100%, so really well done to you.
Nice.
Okay, let's quickly finish this and then we'll get on to the challenge question. So it now says to us, how many moles of water are present? And I just want to go through that very quickly, because it sometimes comes up. In 250 centimeters cubed of a solution, we've got to assume that the mass of water, you'd have to be given a little bit, or you could make some assumptions to say that 250 centimeters cubed of the solution is approximately 250 grams of water. So just to give you an idea of, we know exactly where we're at. This is a bit of an approximation, but we're going to do it like that. So we're going to say to ourselves, well, so what's the mass that we're dealing with? The mass is 250. What's the molar mass of water? I'm doing it on the side here. H2O. Well, hydrogen is 1, oxygen, and it's 2 of them, times 2, plus oxygen, which is 16. So water is 18 grams per mole. Okay? And we're going to then substitute that in to say how many have we got? 250 divided by 18. And it just gives us an interesting approximation that I want you to understand. 250 divided by 18 gives us 13,88 moles. I'm going to round that off to 13,89. 13,89 moles. So, guys, if we look at that and we say how many moles of water are present, compare the moles of water present to the moles of the salt. 0,1 to 13,89. Hope you can see that there is far more water than there is sodium or chloride ions. The last part of the question, what is the ratio between the number of water molecules and chloride ions? Well, we know that there are 13,89 moles of water. Now we could multiply by 6 times 10 to the 23. We don't have to 0,1 chloride ions. How do I know it's 0,1 chloride ions? Because for every sodium ion, there is 1 chloride ion. We worked out there was 0,1 moles of chloride ions, of sodium ions. So how do we write this as a whole number ratio? Well, I guess what I'm going to do is I'm going to multiply this by 10 to get 1, and multiply that by 10 to get 13,89. And I suppose what I could do then, just to get it a whole number, I would be able to say, let's round that off to 13,9 is to 1. So for every one molecule, one ion of chloride, one of these, there are 139 water molecules all surrounding it. And that's the power of dissolving, the dissolving power of water. Hope you can see that. Very interesting question. Right, let's go to the challenge question, which is even more interesting. We'll see if we've got time to do that question on empirical formula as well. So let's move on. And we're going to say water decomposes. I'm going to write it as a chemical equation because that's the trick to this question. It breaks down into oxygen and hydrogen. Now, is that balanced? No, not at all. We're going to have to balance it, put a 2 in front of that, and we're going to then put a 2 in front of that. That tells me that the number of moles of water reacting are in a ratio of 2 is to 1 is to 2. So for every mole of water, I'm going to produce 1 mole of hydrogen. For every mole of water, I'm going to produce half the number of moles of oxygen. So it asks us, we want to get 25 centimeters cubed of oxygen, and we want to get 48 centimeters cubed of hydrogen. Let's work out the number of moles that we want in both cases, because that's going to be the critical thing. The number of moles of oxygen is equal to the volume that we were given. Oxygen, we want to collect 25 centimeters cubed. So 25, now I must divide by 1,000. Another way of dividing by 1,000 is multiplying by 10 to the minus 3. 25 times 10 to the minus 3 divided by the 22,4. I should really have written the formula, but I haven't. What about the number of moles of hydrogen? Well, the number of moles of hydrogen is equal to the volume over the molar volume, and there you can see what it is. I want 48 of these. 48 times 10 to the minus 3 divided by 22,4. Now, let's quickly get it on the calculator so we can see where we're at. We're going to say 25 exponent minus 3 divided by 22,4 equals, and we've got 1,116. I'm going to round it off to 1,12 times 10 to the minus 3. So I'm going to say this is 1,12 times 10 to the minus 3 moles. What about the hydrogen? Let's go to hydrogen now. We've got 48 divided by 1,000. Oh, that's 10,000. Let's do it again. 48 divided by 100,000. There we go. That's 1,000. Equals divided by 22,4 equals. And this gives me 2,14. 2,14 times 10 to the minus 3. 2,14 times 10 to the minus 3. Now, guys, what you've got to do here is you've got to recognize that there is a limiting reagent here. You might have too much hydrogen or too little oxygen. You've got to choose the right ratio. You want to make sure that you don't choose too little water that you can't make one of the products. So one is going to be more than what you need. So what's the ratio? 2 is to 2, and here's the other important ratio, 2 is to 1. So if I take enough water to make 1,12, let's take that 1,12 exponent minus 3, multiply it by 2, because the ratio tells me that I must multiply it by 2. And then you can see I'm going to get 2,24. So that tells me I'm going to make enough hydrogen. Can you see that? It's making 2,24 where I only needed 2,14. However, if I had chosen this ratio, I'd chosen the wrong one, then I want to write this down. I'm going to need 2,14. I'm going to need 2,14 times 10 to the minus 2,24 times 10 to the minus 3. I'm going to need that because you see, if I choose the other one, and I can always check it, 2,14 exponent minus 3, and I divide that by 2, take a look what I get. I only get 1,07. I'm not going to be able to make enough oxygen as was required. So the answer that I'm looking for is I need 2,24 moles of water, because the number of moles of hydrogen that I'm going to need, it needs to be the same as the number of moles of water. So I'm going to use this one, because if I use that one, I'm not going to have enough. So I'm going to ignore that. I'm going to say I'm going to now use the ratio 2,24, 1,12 times 10 to the minus 3 times 10 to the minus 3. And this one will obviously be 2,24 times 10 to the minus 3 as well. Now, guys, we're running out of time, but I hope you can see that by getting the number of moles, I've done half the work. The question that I was asked, is just to confirm, is what mass of water will I need? So I know the number of moles, the mass, or let's just do it the proper way. We often get a little bit used to doing it. Mass over the number of moles. We know the number of moles. We know it's 2,24 times 10 to the minus 3. We want the mass. We know the molar mass. We calculated it just now. So what I'm going to do is I'm going to take that value that I had on my calculator, and I'm going to multiply it by 18. 2,24 exponent minus 3 times 18, and this will give me my mass. So my mass of water that I need, it's almost unbelievable. It's only 0,08 grams. Let me check that. 0,04 grams. Even worse. 0,04 grams. That's the minimum amount of water that I'll need. 0,04 grams of water. Amazing. To produce all of those gases, that's the minimum. I hope you can see that. Very, very small amount of water produces a lot of gas. Interesting stuff. The reason of that is because it tells us that there are so many molecules, even in one tiny little droplet of water. Abby, are there any questions? Quickly.
Awesome, and congratulations to everyone that got the right answer. Well, the question that everyone is struggling with, it's the mole calculations formula. So if you can just go over the formula again.
Okay, guys, there are three formula. So it depends on what you're given, and I hope I've illustrated that. If you're given mass, then the number of moles is mass divided by molar mass. If you're given volume, then the number of moles is equal to the volume divided by the molar volume. And if you're given the number of something, the number of atoms or that, then it's the number divided by Avogadro's number. So what do you notice in common? All of these have the number of moles. So there are three ways. In fact, there are four ways of finding number of moles, because we also worked with concentration. Concentration is equal to number of moles divided by volume of solution. So we can find number of moles in different ways. But please remember, a mole is simply a very big number. Okay, with that, over to you.
Thank you so much, John. And guys, thank you so much for tuning in. Remember, we're always here to help you guys. We've got a help desk that is dedicated to help you guys. For more information, go to land.mindset.co.za/helpdesk. But from me and John, it's been an awesome show, and we love you, Mindsetters. We live in you in peace.